How can the formation of a coffee stain be helpful in detecting toxins in concentrations as low as 1 part per trillion?
When a colloidal droplet dries, it forms these fascinating patterns that are due to a complex combination of many factors such as colloid-colloid interaction and colloid-substrate interaction. This is called the coffee stain effect, even if there is no coffee involved. And we can control all these factors to generate patterns that can be harnessed for some very useful applications, such as in the detection of toxins that could be attached to the colloids.
For example, a colloidal suspension of gold nanorod stabilized with a surfactant called CTAB can be allowed to evaporate on a cleaned silicon substrate. During the evaporation of the colloidal droplet, the gold nanorods are transported to the edge of the droplet due to capillary forces. As the evaporation proceeds, more number of gold particles deposit at the edge of the droplet due to a balance between repulsive electrostatic force and attractive van der Waals and dipolar forces between the nanorods. These particles self-assemble and form a highly ordered structure.
This immediately became interesting for surface enhanced Raman spectroscopy for detecting minuscule amount of any substance using metallic surface like gold or silver. We set out to test the limits of detection using this technique, focusing on rhodamin B. Rhodamin B is a banned dye as it can cause cancer, organ damage and neurological damage even in very tiny amounts, as low as parts per trillion.
We dried colloidal droplets containing gold nanorods and rhodamin on a silicon substrate and allowed them to form an ordered structure. We found that the optimum concentration of gold nanorods was 1.2 nanomole. That could be capable of detecting rhodamin even at picomole concentration, which very few studies have achieved.
As Raman spectroscopy is being used increasingly nowadays for food testing, our technique can be standardized for the detection of dyes such as rhodamin. Our technique can also be used to detect other adulterants which can be harmful even if in very minuscule amounts.